Welcome, everybody. Welcome to lesson 9 of our Power BI course. This wonderful course. We've been on a journey from lesson 1 till now. In lesson 8, we started with an introduction to DAX, and we had a wonderful introduction. And so, if you have not seen the lesson 8, please go back to lesson 8 before watching this lesson, because the lesson 8 will help you set the right foundation to understand DAX. And in this lesson, we are continuing from where we left off. And so we will continue with the foundations of DAX, and we will get to somewhere in the middle, and we will definitely have a final lesson on DAX to cement our training on DAX. And so let's go through this lesson. And one motivational message I have for you today is that don't make excuses for why you can't get it done. Focus on all the reasons why you must make it happen. Yes, some people think Power BI is difficult. It is not difficult. It is not difficult. It is easy. Even DAX is easy. Even DAX is easy. Compare DAX to writing code in Java, compare DAX to writing code in C++, and even with Python, DAX is very easy. It's just a matter of you getting familiar with it, okay? You getting used to it, and you realize that it is actually very, very easy. This cannot even be compared to Python. Python is easy, but DAX is easier. You just need to understand how it works, and you just have to get used to it. And one of the things I'm going to tell you today is that don't worry too much about it. Don't worry too much about DAX. Just get exposed to DAX. Once you get to see how it works, don't worry too much about it. Once you start working with it in the field, it will become part of you. Once you start working with it, once you start using it on a daily basis, you realize that this is nothing at all. Yes, so if you are now being introduced to it, it may look some way, but it is not difficult at all. It is not difficult at all. Just get some exposure, and that is what we are doing in these classes. And once you have that exposure, and when you start working with it, you realize that you will understand it. The DAX you need, you will meet it when you are on the field. So don't worry too much about it, and don't make any excuse about this class. Let's focus on why we must make it happen. And this class is one of the most important classes. This course is one of the most important courses that will really make you ready as a data analyst. So let's think about that. Let's think about that. And no matter what we have to go through to get it done, let's get it done. And no matter what you have to go through to get your certification, get it done. Let it be something you really push for, you fight for, and you make it happen. So we want you to get your certification. We want you to complete the training, get your certification, and make sure you add this to your portfolio. All right. So welcome to Power BI, Microsoft Certified Power BI Data Analyst Associate Certification. And this particular course is preparing you for the field and will also help you get your certification. And this learning structure has been a guide that has really made us get a feel of Power BI. After going through all of this, we can attest to the experience we have acquired, the knowledge we've acquired, the experience we've had, and what we've been able to achieve with this lesson. So now we are on DAX, which is the wonderful language, and data analysis with DAX in Power BI. And this is part 2. Like I mentioned in lesson 8, we had the main introduction to DAX, and it was done really well. So please, if you missed that, please go back and watch it before this one so that you get the understanding of DAX. And this particular language, data analysis expressions, language for creating calculated measures, business logic, and custom expressions in Power BI. It is extremely important that we understand this. By the end of this lesson, we will be able to write, apply, understand, and interpret that expressions like a real-world data analyst by creating measures, applying conditional logic, and building custom calculations for dynamic, insightful, and context-aware reporting in Power BI. We learned that Power BI, DAX in Power BI is what makes Power BI so interactive. So when we think of the interactivity in Power BI, when we think of how Power BI does all of its filtering, it is because of DAX, and DAX is really, really powerful. In our previous lesson, we understood what DAX stands for, and it stands for data analysis expressions, data analysis expressions. And when you think about it, it draws attention to expressions. And so we are talking about expressions within data analysis, and it is called expressions because DAX is built around expressions. Yes, not traditional programming code. So DAX, again, is data analysis expressions. So let's think of expressions. And when we think of expressions, expressions brings to mind mathematical formulas. All right. So data analysis expressions is actually called expressions because it is built around writing expressions, not like writing code like in Python and in Java and in other programming languages. And so as you are learning this particular language, you have to understand that it is made up of expressions. And an expression is a combination of values, operators, and functions and references that evaluates to a single result. So when we say expression, we are talking about combining values with operators. So you have an operand, you have an operator, you have operands and operators together trying to evaluate to get a result. So that is an expression. So anytime you think of expression, you think of these kinds of calculations. In DAX, we introduce functions. And so instead of just using values, you can use functions to perform your calculations. You can also make references to columns, make references to tables, make references to other objects within Power BI. And so when we say an expression, it is a valid combination of values, operators, functions, and references that together tries to evaluate to get a single result. And so when we say data analysis expressions, it lets us understand that this is a language made up of expressions. So let's think of it more mathematical than in traditional programming languages. So unlike full-fledged programming languages that involve complex procedural code and control structures, DAX focuses on calculating values. All right, so the focus of DAX, and like I said, when you think of DAX, you should think of expressions. And when you think of expressions, you should think of calculations. All right, so the language looks like that. It's a language of calculations. It focuses on calculating values. It focuses on aggregating data. So today we'll talk more about aggregations and aggregation functions. And when we say aggregating data, we are talking about combining or trying to get a summary of data. All right. So the formulas and the functions within DAX, they are all designed to allow you to calculate values, to aggregate data, to simplify it, also to filter rows for use in your Power BI reports. And so this helps us understand the kind of language we are talking about. That's why we say we should think of this like Excel languages. So that is all about building formulas to perform calculations. Yeah, so this is not like traditional programming languages. This is more like learning how to understanding how to perform calculations within your Power BI report. And a formula is made up of one or more expressions. So DAX is all about building formulas. So to learn DAX, you should just understand that you are going to learn how to build formulas to perform calculations. And in these calculations, you are going to be including functions. Functions are also formulas, but they are predefined formulas, all right? So using these functions, you can perform calculations, you can make references to certain columns, certain tables, and so on. And so DAX, again, is all about formulas. And a formula is made up of expressions. This is why it is an expressions language. It is a formula language. It is made up of formulas. It's made up of expressions. And so when we say a formula is also an expression made up of one or more expressions. So hence, DAX is classified as a formula language. So this is important to understand because once you know that this is a formula language, you understand that it is going to involve a lot of calculations. All right. And the easiest way to understand this is to think of it like Excel formulas. Because if you have used Excel before, you understand that to perform any calculation, you need to write a formula. And there is a way that those formulas look like. And DAX is just like that. It's just like that, just more powerful and made specifically for Power BI and its associated applications. And so this makes us understand what we are trying to achieve. And to achieve this, you just have to get exposed to it, and you just need to be comfortable with that environment. You don't have to memorize everything. It's not about memorizing everything. It's just about understanding how it works. Once you understand how it works, you will master it with time. All right. So the work you'll be doing in Power BI, you will be able to get all the DAX you need to make it happen. All right. You don't have to memorize everything. Every project will lead to what you need to know and what you need to use. And anytime you are working on a project, you have to you will do some simple research, simple calculations, simple lookups to find out how to perform calculations to achieve what you want. So once you understand the syntax, so the syntax is what is most important. Once you are familiar with the syntax, when it comes to working with DAX, you will be able to solve any DAX problem when the time comes. So what we are trying to do is to let you get comfortable with it, understand how it looks like, and the rest will come when you start working with it. All right. So in our previous lesson, we mentioned that DAX is used in Power BI, is used in Excel, in Power Pivot, and it's also used in SSAS or SAS Tabular Model. It's used in Azure Analysis Services and Microsoft Fabric, which also uses Power BI. And we talked about the uses of DAX within Power BI. In Power BI, we use DAX mostly to create calculated columns. We use DAX to create measures, to build calculated tables. So in our previous lesson, we created some calculated columns, we created some measures, and here you can create whole new tables. We'll get there. You can create a whole new table. You can also perform what is called time-based analysis or time intelligence, and you can definitely build interactive dashboards with your DAX. And we talked about certain core concepts that you need to understand to be able to use DAX. And we mentioned row context, and we've also mentioned filter context. And this is really important. We explained this in our previous lesson. And so once you go back to those lessons, you will have the understanding. And we mentioned that for you to really understand that, it's all about having these basics. All right, understanding what row context is, what filter context is, and we explained it in our previous lesson. And we mentioned calculated columns and measures, of course, and context transitions and basic DAX syntax and functions. So what we are saying is that for you to get a hold of DAX, these are the things you need to pay attention to. You need to understand what is called row context, filter context, understand calculated columns and measures, which we talked about it abundantly, understand context transitions, how to transition from one context such as row context to filter context and all of that. And you need to understand the basic syntax and then some basic functions and you are good to go. All right, so we already explained row context. I'll not spend much time on this. And understanding row context and filter context is really crucial for anyone learning DAX. This is what really makes you get the understanding of what you are dealing with. This is what makes you think like an analyst for you to know whether you are dealing with row context or filter context. And this is very, very important. We mentioned that row context is a concept in DAX that exists when a formula processes data one row at a time. So whenever data is being processed, your DAX code or your DAX formula is either operating within a row context or a filter context. It's a simple concept that you need to understand. And we said row context exists when DAX evaluates an expression row by row. So any DAX function that deals with data processing or calculation in the background, row by row, we say that it is operating with row context. And then to put simply, row context is the idea that Power BI looks at one row at a time when calculating something. Yeah, so this is simple. We explained it well in our previous lesson. And don't overthink it. Just remember, if Power BI is calculating something row by row, then row context is happening, as simple as that. Then when we say filter context, it happens when filters are applied to columns or tables before a calculation is performed. So when a formula is performing a calculation, if it performs that calculation on a filter instead of row by row, then we say that is filter context. And filter context is the idea that Power BI filters data first, then performs the calculation. So before the calculation is performed, there is a filter context that creates a subset of the data through your filters and your slices. And when that filter is created, then the calculation is performed on that. All right. And if you use Power BI, you understand that measures always require filter context and calculated columns usually works with row context. All right. So we've already explained this. We will not go back to it. One last thing I'll say about it is that measures are evaluated in filter context and calculated columns in row context. So this is exactly what I just said. So when you are creating measures, you are operating with filter context because they are evaluated in filter context. And when you are working with calculated columns, you are operating with row context. So all of these things are simple and clear if you understand these points. All right. So with what I'm saying, if you're not hearing anything, is because you have not taken the prerequisite for this lesson. And the first class explains it for you to understand what a measure is, what a calculator column is, what a filter context is, what a row context is, and it makes sense to build upon it. But if you don't understand those concepts, then it makes it hard to understand. And lastly, we mentioned context transitions as well. All right, so this is where we ended our previous lesson, and we want to get into the basic DAX syntax. And after understanding the basic DAX syntax, you are really ready to look at DAX in a very comfortable way to be able to understand it. So DAX syntax refers to the set of rules that define how DAX formulas, how to write DAX formulas, or how to write formulas in DAX. So these are the set of rules. And so learning DAX is really simple. Having the understanding of these concepts that we mentioned before, and also having understanding of the syntax. And it guides you to write your formulas. Understanding DAX syntax helps you build expressions that Power BI can interpret correctly. So once you have the syntax in mind, you are able to build the right expression. So this is how DAX looks like. So once we mentioned that DAX is an expressions language, this is how it looks like. Just as simple as this. Yes, DAX is a formula language. It's an expressions language. And so to write DAX, you usually have a formula and then you have your expression. So your formula equals to your expression. It's as simple as that. So this is the name of the calculated column, the measure or the table that you want to create. And so any object in Power BI that you want to create through DAX, you just write an expression for it, but then you need to create a name for it. All right. So here we call it a formula name or the name of your calculated column. If you are creating a measure too, it will be the name of your measure. If you are creating a new table, the name of your table and so forth. And then you need an assignment operator. And then you also need your expression. Your expression is the logic or the calculation you want to perform. So this is simply how DAX looks like. You have to have your formula and then your expression. Now, to talk about the expression, all DAX formulas follow this basic structure. So what you need to understand is that you will be creating different kinds of objects, like a calculated column, a measure, a table, and then you need to look at the expressions in various ways. So I'm going to take you through a number of syntaxes for different kinds of expressions. So we'll start with a measure. And to create a measure, this is how the expression will look like. So over here, we are using inbuilt functions to perform what is called aggregations. And so we'll be mentioning the term aggregations and aggregation functions very soon. All right. So this is an example. So I'm going to show you about 4 examples of how DAX formulas will look like. And this one is using aggregation functions or functions for aggregations. And what it is doing here is to show us how we create measures following the syntax of DAX. So over here, whatever measure you want to create, you need to have the measure name, and then you need to understand that in DAX, spaces are allowed in your measures. So if you want to create a measure or a calculated column or a table, for the name that you will use, spaces are allowed. Because anytime DAX wants to reference any of your formulas or your DAX expressions, it has a way of bracing the name to refer to it or to make reference to it. And so if you create spaces, spaces are allowed in the names of your measures and your calculated columns. And over here, we have a function for this particular measure. And then calculated columns can reference columns directly and do not require aggregation functions. All right, so over here, what we are trying to create is called a measure. And to create a measure, you can use a function, an inbuilt function to create your measure or to perform your aggregation. Now, as you use that, you understand that calculated columns do not require functions or aggregation functions. If you are using calculated columns, you can directly make reference to columns, and so you do not have to create any aggregation function around the columns. What I mean by that is that over here, we can simply see that we have a table here, and then we also have what is called a column. And so over here, this particular formula or this particular expression is trying to access a column. And to access the column, we have the table name and then the column. And then we are using this function called the sum function to perform an aggregation of it to create a calculation. And so in DAX, the syntax is simple. If you are creating a measure, you need to have functions to perform the aggregation of the measure. But then if you are creating a calculated column, you don't need to use any function. With calculated columns, you can make reference to your columns directly. And I'll show you an example for you to see what I'm talking about. Now, when it comes to the table names, if the table doesn't have spaces, if the name of the table doesn't have spaces, you can simply refer to it like sales as we have here. But if it has spaces, you need to surround it with single quotes to make reference to the table name. For the name of the measure, you can just make reference to it without any quotes, and spaces are allowed. But for your table names, if there are spaces, you need to use quotes. So just like we've been doing, you'll be seeing these single quotes around it. And if it has a single name, you do not need to do that. And DAX makes it very easy for you to write this, because as you start writing, IntelliSense does that for you. All right. Now, anytime you are referring to a column or making reference to a column, it is best practice to have the column name, or sorry, the table name and the column name. And this is called fully qualified column. And it's best to use fully qualified column. What this means is that if you want to refer to a column in DAX, as you write your DAX, the syntax explains that it is best practice to mention the name of the table before mentioning the name of the column. What this means is that it's possible to make reference to a column if you are dealing with a single table, but the best practice here is for you to use what is called fully qualified columns. A fully qualified column is a column that has a table name with it. So this is how it looks like. And with this, you can see that it's a very simple expression. We are making reference to a column called amount in a table called sales. And the function around it is performing an aggregation. It's performing an aggregation. And this aggregation means summarizing multiple values into a single unit. All right. So this example here we are looking at, we can see that there is an aggregation taking place on a single column. And this aggregation means we are summarizing the values into a single value. So this will end up putting all the amounts in that column together and to create a single value that gives us a sum. And sum is not the only aggregation function we have in DAX. We are going to be seeing other aggregation functions, and each one has its own type of aggregation that it does. And this particular one is the most common one for us to see. All right, so over here, again, it says that measures require functions for aggregation. So one thing you need to understand is that in DAX, when you are creating a measure, you will require the aggregation functions. But when you are creating calculated columns, you will not require the aggregation functions. So for example, this is a syntax for calculated columns. You can see that here we made reference to the column profit and the column revenue. Yes, so with this, you can see that we didn't require any aggregation function because this is a calculated column. This is not a measure. And when you are creating DAX, your formula either looks like this or looks like what I showed you before, or some two others that I will show you. Now with this, because of space, this is why I did not write the name of the table, but then this is just the name of the column. And then this is also the name of the column, and you can perform this calculation just by using the column names. And this will work if both columns are in the same table. But if these columns are from different tables, then you will need the table names before you'll be able to perform this calculation. So this example 2 is for a calculated column and using expressions to create row level calculations. And so we understand that calculated columns evaluates in row context. And so this will perform the operation row by row before it will provide the answer we are looking for. So with calculated columns, this is the name, spaces are also allowed, and this is column reference 1. From the same table, does not require aggregation function because this is a calculated column. It can be written as sales profit, or which is a fully qualified column, or simply profit. All right, so this is possible because it is in the same table. And then we have the math operator, and then we have the revenue here as well. All right, so this is to let you see how DAX looks like. So the first syntax you saw a syntax of an aggregation function. And then if you are new to DAX, this is how your DAX will look like. Either you are performing an aggregation on a column, or you are performing multiple aggregation with arithmetic operations, or you are creating what is called a calculated column, as simple as this. So the third syntax I have here is called nested functions. So in DAX, we also have built-in functions that are also created inside other functions. All right, so I'm trying to let you see how your DAX will look like. And I've showed you 2 types of codes or expressions. So these are different types of expressions. The formula name is constant. Spaces are allowed, but the expressions may be like this, may be like the aggregation one I showed you, or it may be like this as well. This is called nested function syntax. With this, what it means is that you may have a function and you may have other functions within other functions. All right, so this is how the DAX looks like, the expression looks like. So here we have divide function, and then we are performing the aggregation of profits in the sales table here with the sum function. And then the syntax of this divide function requires that you use comma before you provide the next value. So instead of providing a single value, we are nesting a function to perform a calculation before finally dividing. So there are 2 calculations within this. So this is here just to tell you that we have nested functions, and sometimes you will write functions within functions. And by the end of this lesson, you are going to see the multiple functions we have in DAX and how to use them. All right. So nested functions let you pass one function result into another function to build powerful DAX measures. So all of these basics, we are already familiar with them. In Python, when we talk about nested ifs or nested functions, we are already familiar with the concept. It means having something within something. So talking about functions, you can have functions within other functions as well. So this is one way we can have our DAX. And then another way here is called a variable-based syntax. So before we end, we will learn how to use DAX to create expressions that involves variables. So here, using variables to structure your DAX measures. So here, we have another syntax. So I'm showing you 4 different ways of how your DAX will look like. So here we have a formula name. And in this formula name, under the expressions part, we have var to instantiate a variable. So over here, you define a variable, and then you provide an expression for the variable. All right, so let me make this variable 2 instead of variable 1 again. All right, so over here, this is how your DAX can also look like. You can create variable or you can define a variable and assign it to an expression. Now, we've already seen how you can have a name assigned to an expression. With this particular syntax, what this means is that you can perform this expression and store it in a variable. But to do that, you need to use a keyword var. We understand the concept of variables already as well. Over here, you can also write another expression, expression 2, and also store it in another variable. To do that, you need to use var. So with this tells us that as we advance in DAX, a time will come we will be defining variables. And to define a variable in DAX, it is as simple as this. Having your overall formula name, whether it's a measure or whatever you are creating, you put the name here, spaces are allowed. Then the expressions part, you can define a variable, variable 1, variable 2, and then you need to use a keyword here called return. All right, return, and then you provide a final expression using your variables. So here you define the variable, define another one, then you return the result using the variables you work with. So let's try an example here. And one example here is simple. So here, the name of our formula is called net profit, which is a measure. And then the variable we defined, who can tell me the name of the variable we defined? So let me see the name of the variable if anyone is in the class with me. What is the name of the variable we defined? All right, so someone says that this variable, let me check my charts. All right, so this variable here is very simple, and the variable is called, okay. All right. Okay. All right. Thank you. All right. So you can see that the variable is called revenue. So this is very simple, just like we've been writing in Python, just that in Python, you don't have to instantiate a variable this way. Here, you have to use a keyword var and then define your variable revenue. Now, this revenue, we assigned it to an expression. So you can see how this expression is simple. This is a simple aggregation of the revenue column in the sales table using the sum function. So that's it. We just wrote the expression down. We just wrote the expression down. Then next, we created another variable. And who can tell me the name of that variable as well? The second variable, let me see the name in the chat. If you know the name of that variable, just tell me in the chat. All right, so we have this variable called revenue. And over here, we have a variable called cost. To define these variables, we use a keyword var. Here to use a keyword var. And these ones here are just the expressions we assign to the variable. So this expression, this is performing an aggregation, and it will create a value out of this aggregation, and it will simply store it in the variable called revenue. Same will happen with this, and to store it here. So over here, you can see that there is really no operation going on here. All we are doing is defining variables, performing this aggregation and storing them in the variable. That's all. But then if you look at return, over here, you can see the operation taking place over here. And so this is a very simple syntax in DAX that we'll be using once we start getting into details. So this is very simple. And I think if you have ever written any Python code before, you should be able to figure out what this is. So here we are deducting costs from revenue. So whatever revenue is over here, costs from here will be deducted from here. Now, we are able to use revenue Yeah. Okay, let me ask this question in the chat. Why are we able to use this called revenue? This is a name that didn't exist, but we are able to use it. Why are we able to use it like that? Why are we able to use it? If you understand my question, let me see something in the chat. Why are we able to use revenue? Why are we able to say revenue minus cost? All right, so let me load my charts. I think someone is saying something. All right, so the reason why we are able to just call revenue is because it is a variable and it's because a value is assigned to it. All right, so these two, they didn't exist. And if you hadn't defined them, it will create a syntax error to use them. There's nothing called return costs in DAX. We are able to say return revenue minus cost simply because we have already defined them as variables over here. All right. Now, the operation you perform here is really up to you because you have a value in revenue, have a value in cost, and you are deciding to perform revenue minus cost. You can do revenue plus cost, revenue divided by cost, revenue times cost, or whatever you want to do with the variables. And so the syntax I showed you here said that first have your variable 1 with its expression, variable 2 with its expression, and then you return the final expression using the variable. So whatever you want to perform with these expressions, you do that using the return keyword. So a time will come when you are writing DAX, you'll see that you write a name, you create a var, and then you create another var, and then you return an expression. And right now you have even seen already how simple this is. So there's nothing really complex within DAX. You just have to get exposed to it. Stick with uppercase for functions. So when you are dealing with functions, stick with uppercase for functions for readability. Stick with uppercase for functions for readability. So instead of writing some like this, write some like this. All right, so an example is here. You can see how some is written here for clarity and readability. Number 2, when it comes to the use of functions, every DAX function must be followed by parentheses, even if no arguments are required. So just like Python, every function needs the parentheses. So this is an example here to show that if you are referring to a function, it needs to have parentheses. So if you look at sum, this sum is a function, and to use it, you need to provide a parenthesis here, and you need to close it. And another rule about the parenthesis is that any parenthesis you open, you have to close it. Yeah, so if you open 5 parentheses, you need to close 5 times. Yes, so we've seen that. Another rule here is that columns are can be referenced directly or with a table name. So columns are referenced like this. So if you want to refer to a column within a table, you need to put it in this brackets, in this square brackets. And then you need to have the table name here. So this is called a fully qualified column, a fully qualified column. It is possible to write only the column, but it is best to write a fully qualified column that begins with a table name. So these are simple rules in DAX. And just to clarify the syntax we've been looking at. Now, tables are referenced directly by name. So if you are referring to the table, just refer to the table by name and it will be recognized. All right. Again, if the table name has spaces, then you need to place your single quotes around them. But if it has no spaces, you can just reference it like that. All right, then one last row here is about the use of comments. So in DAX, we have comments to make your formulas more readable. So DAX allows adding comments. So we have single line comments, just like in Python, but in DAX, this is how comments are written. So this is single line comment. So before you write your DAX, you can write a comment. And if your DAX code has multiple lines, or if your expressions have multiple lines, you can use comments to make them readable and understandable. So this is how a single line comment looks like. And to see it in action, this is how it looks like. So before you write this in your formula bar in Power BI, this is what you write. And here we are seeing how this calculation is performed. We are seeing that there is a table here called revenue. There is a table here called revenue. There is a table here called costs. And you can see that an aggregation is being performed around this revenue. Because it's in the sales table, we need to make reference to it. And then another aggregation is also being performed here. And then both of them are being deducted, or there's an operation using this operator here to perform an operation on this. So this is similar to what we created with the variables. You can also perform your calculation like this. And then you can write a single line comment here to make it readable. And single line comments in DAX or comments in general are there to make your code have descriptive text. Exactly. They have descriptive text just for the reader or your future self to be able to see what you are trying to do. So the comment will be ignored and will not be processed. So any comment you write, it will just be ignored and will not be processed. Apart from single line comment, we have multi-line comments. This is how multi-line comments looks like. And you can write your multi-line comments like this. All right. Next, we will talk about some simple operators, and then we will get into the details. So in DAX, we have arithmetic operators, and our arithmetic operators here, we have addition, which is the same as addition operator, you know. So you have your addition operator here, and this addition operator, you can use it to perform operations here. So talking about the same table, so here you can see that we did not introduce or make reference to the table is because they are all in the same table. So this column and this column are in the same table. All right. So because of this, you can see that we have performed a calculation here with this operator called the addition operator. This is the operator over here. All right. So one question I'm going to ask right now, this particular DAX expression here, is it a measure or calculated column? Who can tell me what it is? Is it a measure or calculated column? Just look at it and tell me whether this is a measure or a calculated column. Let me see in the chat. Is this a measure or calculated column? Let me see in the chat. All right. Okay, so someone says that this is a calculated column. Thank you, Lauren. So this means that Lauren is paying attention. And when I showed you the syntax for DAX, we mentioned that calculated columns are able to make reference to columns directly. They don't require any aggregation function to perform their operation. So over here, you can see that we did not include any function. We just call the column like that. Okay. If you ever want to create a measure and you make reference to a column like that directly, it is going to return an error. So measures cannot behave like this. With measures, you need some aggregations. You need aggregation functions to perform your measure calculation. But for calculated columns, you can make reference to columns directly and perform your operations, and it will do that using row context. All right, so you can see our operator here called subtraction, and this is the same as what we know, and it can also perform an operation here like this. We have multiplication, same asterisk, and you can make reference to this. So with this, we are just letting you understand how that looks like, get familiar with it. Once you have the idea of how it looks like, how it works, you understand how defining variables work and all of that, you really have what you need to really dig deeper. You don't have to memorize too much, just get used to it. Just get used to it. And with time, everything you need about DAX, you will be able to do. So this is not a lesson you need to worry yourself too much to memorize. You just need to get familiar with it. So we have a division operator. This is how it looks like. And you can perform your division like this. So in another language, like in Python, you can perform a division, call a variable, introduce your operator and another variable, and the operation will be performed. But here in DAX, this is how it looks like. And here we know that these are columns. We are dealing with columns, and we are talking about tables here. So you can refer to one column and another column. So what will happen is that through row context, it will perform these calculations row by row. So for each row, it will pick the column, the value, and the total, and then divide it by count, and then create the average for that row, and so on. Then we have exponent. This is how exponent looks like in DAX. This is how to write your exponents. So you have your base and you have your exponents right here. All right. So I want someone to give me an example of using this particular exponent. We also refer to it as power. We also refer to it as power. And here we are saying base raised to the power exponent. Okay, so someone should give me an example of how this can look like in DAX. Think about it for a minute and tell me how this can look like in DAX. How can you use exponents to perform, to create a formula in DAX? Just try something and let me see in the chat. How do you think it will look like? Okay. All right. So over here, what this is saying is that we have a column here called base, but it can be any value at all. It can be any column at all. And here we have another column called exponent. So this bracket here really tells you that this is a column. The bracket here tells you that this is a column. We are dealing with a column within the table. But does it necessarily have to be a column before you can perform the exponentiation? Does it have to be a column before you can perform the exponentiation? All right, so someone says, let me see in the chat. Okay. So instead of writing a column to perform the exponentiation, you can simply use a value and it will also work. So you can call a column and say raise to the power 2 or 3 or 4 and it will work. All right. We also have comparison operators in DAX. And when we talk about comparison operators in DAX, we are talking about comparing two values or comparing two columns or comparing two situations and coming out with what will happen after comparing. Now, in Python, we are used to using the double equal to sign. Here, it is also called strict equal to. But in DAX, this is not valid. This is not valid in DAX. So in DAX, we don't use a double equal to. So if you want to compare, and if you want to assign, we still use this simple equal to. In Python, we can assign with a single one, but to compare, we need to use a double. All right, and very soon we are going to learn how if works in DAX. And you can see that if is very, very simple. And once we get there, you see how it works. Just like Excel, if you've used if in Excel, you can see that it's very, very simple. So here it says that if region, and this region, we know that this region is a column. So if region equals to east, so this is where the condition is. If region is equal to east, then we have yes and we have no, or we have true and we have false. So the syntax for this if is very simple. Once we get there, you realize that it's very, very simple to use it. So it's saying that if the region is east, use the number 1. Okay. So in a new column, you can say that if the column called region has a value of east, then this should happen. Input 1. But if not, input this. It's always like that. So over here, we are saying that if status is not equal to closed, then this should happen. Else, this should happen. All right. So here we are talking about another operator, comparison operator called not equal to, and this is how it looks like. So if the column called status is not equal to close, then this should happen. Now, why is this in double quotes, but this one is not in any quotes? Who can tell me why this is in double quotes? Why is it in double quotes? Who can tell me in the chat? Why is it in double quotes? All right. So whenever you are using if in DAX, you need to state your expression or your condition. And once you have your condition, after your condition, you need to provide 2 values. One will be used if this condition is true, and the other will be used if it is false. So this is a syntax. If as a function, then you open your parentheses, then your expression comes here. Whatever you define here, you have to bring comma and provide 2 values, one for true, one for false. That means if this becomes true, the first one will be activated. But if it is false, the second one will be activated. For example, if sales is greater than 500, then input yes, else no. What are we trying to calculate here? Maybe we are trying to look for greater than. Okay, so this is an operator. So if sales is greater than 500, yes, it is greater than it, or no, it is not. All right, so this is how the if syntax looks like, and we will get to it. All right, then we have the greater than or equal to, less than or equal to. Then we also have what is called text concatenation. And for text concatenation, we have this operator here to concatenate. To concatenate, here we use the AND operator here to concatenate in DAX. So this is very simple. And anytime you want to concatenate, you need to introduce your first column, then you use this and then you can add to it. Here we are adding space before adding the last name, so that the first name and the last name will not be joined together, but will be separated by a space. So this is a concatenation operator for strings or for text. So this is called text concatenation. Over here, I asked a question why we have this true value in quotes, but the one was not in quotes. So I was waiting for the input. I think my chart is still not loading. All right, good. So this one is a string or text, and then this is an integer. So if you want to input an integer, you need to use without quotes. And if you want text, you need to use your quotes. So anywhere you see text, you see the quotes over there. Anywhere there should be text, you see the quotes over there. You open and you close. But where you have integers, you don't see them. All right. Then lastly, we'll talk about the logical operators. So for logical operators, this is what we have for AND. For AND, this is a symbol for the AND operator. And this is different from the text concatenation operator. For the AND logical operator, you use double. So to read this code, it says that if sales is greater than 1,000 and region is equal to west, your two values again. So anytime this if is called, it is very, very simple. Your expression is here, then comma, then one for true, one value for true, and then one value for false. This particular expressions box here, it's a compound expression because of the logical operator. This means it is going to evaluate both the left and the right before it knows what to do, before it knows whether it is true or false. So anytime we are talking about logical operators, we are also looking for true or false. If it is true, this will happen. If it is false, this will happen. All right. We also have what is called the OR logical operator, and the OR operator in DAX uses the double pipe. So it looks like this, and the pipe is under the backspace when you press shift. So the same way we have if region is equal to east or region is equal to south, then we have true or false. So we don't know what will happen, but row by row, if these conditions, because of the OR, if either of them is true, then we'll have zone A. But if both of them are false, then we'll have zone B. And I remember in our Python class, we showed a truth table where we saw how the AND performs its evaluation. With the AND, both of them have to be true before you get true. But with the OR, either one has to be true before you get true. In DAX, we also have what is called a NOT operator. And the NOT is a negative or negation operator. So here, you have one column here called is active. And then you said if not is active, then true, else false. So row by row, if it's active, if it is not is active, then it's true. So we'll write inactive. But if it is active, then we'll write active. As simple as that. Then lastly, we also have the in operator here in DAX. So in DAX, we also have the in operator. So let's see how that works. For the in operator, it says that if region in any of this, okay, so there's a column here called region. If this column is part of east or south, then show true, else show false. Not selected. All right, so the in keyword is also here. So you can have in, just provide your curly braces, and then provide your list of or your set of values that will be compared against a column. So this is a column. All right. All right. So we have what is called the categories of DAX functions. Categories of DAX functions. And this is what will really lead us into the final part of the lesson so that we will be able to perform serious calculations with DAX. So to understand, in this lesson, we've seen the basic syntax of DAX. We've seen the rules, we've seen some operators and how they are used. And now we want to look at the categories of DAX functions. So DAX functions are categorized to help users build logic depending on the type of analysis required. So based on the analysis, you have a category of functions that you work with. So these functions are categorized to help you build your logic depending on the type of analysis you are performing. So based on your analysis, you will know which category to use. So the first category is called aggregate or aggregation. So there are different types of functions in DAX. We have the aggregation functions, which we will be looking at them extensively. So after this, in this lesson, we'll talk about them, aggregation functions. After that, the advanced ones will come in the final lesson. So today we'll be looking at aggregation functions. And these aggregation functions perform arithmetic across columns and tables. We also have date and time functions. It works with calendar-based calculations. We also have filter functions to create filters dynamically within formulas. Wow. Then we have logical functions to perform logical tests and branching as well. Then we have our text functions, mathematical functions, we have information functions, we have time intelligence functions, we have table functions, we have parent-child functions, statistical functions, financial functions, and lastly, we have functions even for relationships. So in that, there are categories of functions for different things. And what is important is for you to be aware of all of these types of functions. You don't have to memorize them. With time, the ones that are useful to your work, you will know them really, really well. All right, so let's talk about the aggregation functions, and then we'll try some quick demo and we'll wrap up this particular lesson. All right, so this lesson plus the previous lesson 8 builds a solid foundation for you to be able to advance in DAX. So in our next lesson, we will be dealing with the advanced DAX where we now move to the next level. So now we've seen how the syntax looks like. We've seen the rows. We've seen that there are different types of functions. So the functions we are going to look at now, we understand that these are under aggregation functions. We will understand that we have date and time intelligence functions as well. So once we get there, we will see that those are also functions that are used in DAX. All right. When we say aggregation, we are talking about you combining or summarizing to derive a single value. So aggregation functions are used to summarize or combine values. So this is really simple. In DAX, you can see that, for example, we have a column. This is a column. So everything we are talking about here, we are talking about tables of data, and we are referring to columns, and we are referring to rows as well for row context. So for columns, if you refer to this particular column, especially if you are creating a measure, you cannot just reference the column directly. You need to perform an aggregation on it. So this is an aggregation because we are creating a measure. And this aggregation here, what it does here is to give you the total of the column. So the moment you use sum, it means you want the total of the column, and everyone here knows what that means. Now, the same column, you can choose not to perform the sum aggregation, but you can choose to perform what is called the average aggregation. So there's a function called average. So it is one of the aggregation functions. And what we do with it is to perform the average of the same column. So you can see that we are dealing with the same column called amount. There are several rows of data under the column. But this particular function is going to perform an aggregation. What it means is that it is going to find the mean. To find the mean, think of the table. It will run through from the top to the bottom, and it will put all of them together and find a single value. And this function here will output the mean or the average. Remember, you can use formulas to perform all these calculations, but when we say a function is a formula that has been built in and has been named. So you don't really have to do anything. You just have to call it. Once you call that function, whatever operation lives within that function is what will happen. So for sum, we get a total. For average, we get a mean. And then for mean, it's so interesting. It will give us the smallest value, and then max will give us the largest value. And this is also for aggregation. This is also for aggregation. All right. So I'll talk about 4 more or 3 more. When we talk about aggregation functions, we also have 3 additional aggregation functions. One is called count. And for count, you also assign count to a column, just like you assign to your sum and your average. You assign count to a column. And for us to move on, I just want to be sure if everyone is following. This sales, what is this sales? What is this? The sales. What does it stand for? What does it stand for? Let me see if anybody in the chat can give me a simple answer. What does that stand for? The sales. What does it stand for? The sales. All right. Today my chat is not loading, and I hope my audio can hear me. All right. So the sales is the table. Thank you, David. The sales is a table. All right. So when you see this bracket, we are referring to the column. So over here, you can see that we are simply talking about a column. Now let's go back. You can see that they are all referring to just a single column, but it's a function that changes the operation. Okay, these are called aggregation functions. Here, there's one aggregation function that can be performed on ID because this aggregation function is called count. What does it do? It will count non-blank values. And at the end of the day, it will tell us how many rows we have. So if we apply it to the students table, because it is a count, we need to provide it on a column. And the best column to use is the ID column. It is not adding them, but it is counting them one by one. So the ID is a great column to use over here, mostly because it looks for non-blank values. So mostly in the IDs, we usually have the values in the data set. Even if the other columns do not have their values for the ID, we usually have the values. Then there's another aggregation function called count A, count A, count A. Please put count A in the chat for me, count A. Count A. So let me see someone put count A. Okay. Okay. So my chart has a misbehavior. All right. So we have count A, which is another one. It's also assigned here to perform aggregation on a column. This column is called comments. And its job is to count non-empty entries for both text and numbers and more. So non-empty entries, non-empty entries, non-empty entries, non-empty entries. All right. So one assignment I'm going to give you is to find a difference between non-blank and non-empty. Non-blank and non-empty. In one of our lessons, we had to make some cells, we had to make them blank before we're able to perform certain calculations on them. All right, so keep this in mind, non-blank, non-empty. Do some research on it, and next time I'm going to ask you. Then the final one we are going to look at under aggregation functions is called count rows, count rows. And here we assign it to a table. So you can see that when you are dealing with tables, you don't need to provide any columns. Sorry, you don't need to provide any brackets. You can just go ahead and provide the name of the table, just like we mentioned when we started. So count rows will provide the total number of rows in the table. All right, so once you use count rows, you are dealing with tables. And then we have count. With that, you provide a column. And then count A, you can also provide a column for that. All right, so these are the aggregation functions within in DAX. And we have multiple types of functions. We have text functions, we have date and time functions, we have filter functions, logical functions, and we'll be looking at them and whatever is relevant in this lesson in our next lesson. So right now, we have a quick exercise. To wrap this particular lesson, we will do some quick demo. And at this point, we'll take a very short break. And then when we return, we'll do a quick demo and we will apply what we have been able to learn. So I'm going to give you simple exercises and I'll let you perform it with the data set we are going to be using. So after the break, I'm going to show you the data set we are going to be using, the same data set we used in our previous lesson. And so you already have it and we just load it in your Power BI. This particular lesson is just designed to give you the foundation of DAX. And this together with the previous lesson gives you the basics and the introduction to DAX. And the next lesson, we will move on to advanced concepts to wrap up the lesson on DAX. All right, so here we have a number of exercises. And the first one here is for us to create a calculated column to compute revenue. So we have a data set that we are going to import into Power BI, and then we'll perform a simple calculation. It says calculate the total revenue for each transaction by multiplying the quantity sold by the unit price. So we'll go through a number of exercises, and through these exercises, we will be able to get a feel of what DAX Power BI looks like. So let me launch my Power BI, and if you have yours, please go ahead and launch yours as well. Let me share my screen well so that we can see it. And last time we imported a certain data set. It's the same data set we are going to be using. And so let's click on blank report and let's import it again. If you have it imported already, you can still use what we worked on last time. I'm choosing not to recover it. Let me just cancel this. and we'll import it again. So over here, you can click on get the data from an Excel workbook, go to where the data is, and the data is here in lesson 9. This is the data sets. I shared it with you in the previous lesson, and it's the same data we downloaded from GitHub. So if you don't have it, you can go to github.com/RetaAfrica, go to the Power BI data set and download this data set called DAX sales data sets. All right, so there are other data sets we'll be using, but in the next lesson, I'm going to share them with you. For now, we'll still stick to the old one. It's called the basic DAX data set. So let's import it here. And it is on GitHub. You can find it on our GitHub platform. And then we click on sheet 1 to import this table here, sheet 1. And this, we are actually going to rename it, and we are going to call it sales. So over here, you can see that we are dealing with a table called sales, but our table here is actually called sheet 1. So we don't want to use it with this name. We are going to rename it to sales. All right, so let's call this sales. And now that it is called sales, we can check some of the columns within it. It has a column called category, units, cost per unit, order dates, order ID, product quantity, and unit price. And if you go to the table view, you are going to see all of the rows and columns here as well. Now, this exercise is simple. We are going to create a column, calculated column called revenue. Calculated column here called revenue. And this is going to be made possible by using the column quantity and multiplying it with unit price. So with this, we can do this in DAX to create a calculated column. And we did this in our previous lesson. And so this is nothing new. To do that, you can come to the table tools and click on new column. You can also, even in the report view, you can go to your modeling tab, click on new column over here, or you can even right click on the table here and click on new column. So here you can click on new column, and this column is supposed to be called revenue. So over here, we come here, we call it revenue, and then we use the two columns that we are supposed to use, quantity and unit price. So here we have quantity. Once you type quantity, it will bring out the sales. So you can see sales quantity. And then you say times unit price. Unit price. All right. So this will give us what is called revenue. And in our syntax, we learned that you can use single quotes around this. It's possible to write it this way. So instead of quantity, like I wrote it before, you can write it this way. But then the single quote here is not really necessary unless it's really not necessary if the table doesn't have spaces. So it will work like this, and it also work with this. But if the table has spaces, then you need a single quote to be able to reference it. All right, so same with this, we can use a single quote to reference a unit price here. All right, then once you are done, you can click on this to commit it or this to cancel it. So if you commit it, since it's a calculated column, if you go to your table view, you should see it here as a column. So it has been created here for you. So this exercise 1 is very, very simple. And then we have exercise 2. With exercise 2, we are creating another calculated column called to compute the cost. So calculate the total cost for each transaction by multiplying quantity sold by cost per unit. So we have cost per unit, we have quantity. So this is going to be called cost. This is going to be called cost. So I want you to try this on your own. So the same table, you can add cost to it, cost to it. So let me go to my table and then we create a new column. Let's create a new column. This column, remember the name is cost, and the costs, what are we using to calculate the cost? To calculate the cost, we are using quantity times cost per unit. So we are taking the unit cost and we are also multiplying it by the quantity. So you can just simply type quantity and you can see sales quantity times unit costs. So you can see cost per unit. All right, so this is really, really simple and you can commit this here or you can press enter to commit it. And once you do that, you have cost. So this is very, very simple. So we've been able to add two calculated columns. You can see how simple this is. All right, so for the third one, it says we need to calculate profit. All right, so think about this. To calculate profit, we are going to create another column to calculate profit. To calculate profit, the goal of this lesson is for you to understand that you need to use DAX to calculate the profit. You need to use DAX to calculate the profit. And to do that, you need to create a calculated column. And you should be able to understand with your own logic how you can achieve profit. So if I call this profit, I know that I will take our revenue and subtract our cost from it. So you can see that we have revenue minus cost. All right, let's do away with the table name here. And let's leave revenue. And let's do away with the table name here. And let's leave cost. And let's commit this and see if we'll get an error. So based on the syntax that we're introduced to, if we commit this, let's see if it worked. So let me see in the chat. If it worked, type yes. And if it didn't work, type no. If it worked, type yes. If it didn't work, type no. So let me see in the chats and I can see that this is wonderful. And all right, thank you. All right, so over here, you can see that this syntax also works. So looking at the various syntaxes that we saw, we understand what works and what doesn't. All right, so this is to help us to create calculated columns that we'll be using later on. But from the aggregation functions that we learned about, we understand that calculated columns don't really require aggregation functions. They don't require functions. So you can see that all the three calculations we did, or the expressions we wrote, they were all without functions. And so in the exercise 4, we are going to perform our first aggregation, and we are going to create a measure to calculate the total revenue. So this is a measure, and it will create a single value. So create a measure to calculate the total revenue across all sales transactions. All right, so what I'm going to do is to let you solve this without looking at the code here, so you can figure out how to do it. And you can see that if you want to calculate total revenue, you just need to call the column revenue, and then you just need to perform the aggregation here called sum. Very, very simple. So let's try it here. And for the next one, I'll remove the code and see if anyone can get it right. All right, so here we are not creating a measure. We are not creating a measure. Sorry, we are not creating a calculated column. We are creating a measure. All right, so let's create our first measure. To do that, there are several ways of doing it. You can right click on the table and select new measure. You can go to table tools and select new measure, or in your report view, you can click on the modeling tab and select new measure. All right, so this new measure, let's try making reference to revenue and see if it will work. You can see that I'm typing revenue, but revenue is not popping up. It is because there's no row context within measures, but by the fact that you selected measure here, this is not a calculated column, this is a measure. So measure do not have row context, so they do not recognize the rows. So to do that, I need to introduce an aggregation function first. So let me introduce sum, and you can see that when you open the parenthesis, you have, it is in red, and when you close it, then it becomes blue. So you should always make sure you have blue. Now that I have an aggregation function, I can now access revenue like this. So now it is going to work because now I have a function. All right. So this is a sum of our revenue, and the name of the measure is supposed to be total revenue. And when we're looking at the syntax, we learned that you can add space here, and that's okay. Spaces are allowed. So this is really fine. Let's go ahead and commit it, and we have total revenue. So this is a measure that we can use on a card. We can use to perform multiple calculations here. So when you come here, you can see your total revenue right here, and this is so wonderful. And you can use it in most of your visualizations here. Over here, we have a card. You can select a card visualization, and this card visualization, you can apply your total revenue on it, and you can see the total revenue display. So this is a single value. This is not like the row context that gave us the values row by row. This is an aggregation of all the values here into a single value. All right, so that is it. Let's look at the next. Let's look at the next question. Let me actually, okay, let's just look at it because of time. So exercise 5 is to perform the average unit price. So create a measure that returns the average unit price of all products sold. Average unit price. So there's a column called unit price, and we want to find the average. So that is very, very simple as well. And all you need to do is to create a measure. Remember, this is a measure because this uses the aggregation functions. So let's say this measure, let's use the function called average. Without this aggregation function, we cannot access the value, the column unit price. But now we can access unit price by typing unit price, and it will give us unit price. So this is just a single column like we've been seeing, but this aggregation function will perform a special calculation on it so that we can get a single value. So here, let's call this average unit price. We can commit it here. All right, so let's commit and let's create a card here. And let's input it here. So average unit price, the moment you create a measure, the measure will appear here. So average unit price is a single value. So you can see here average unit price. And it became average unit price because we named it average unit price. If you want to edit it, you can double click on it and come here and change it here. So instead of this, you can say average price. Whatever you rename, you can commit again, and you can check your visualization, and you can see that it has been updated here as well. All right, so we have two measures here, and let's continue. Number 6 says that create another measure to find the lowest unit price. Lowest unit price. So this is interesting. Let's create the lowest unit price. So let's go to modeling, and we'll create a new measure. And this one, what is the aggregation function we are supposed to use here? Who can give me the aggregation function for the lowest unit price? Remember, the column is unit price, but we need to provide the right aggregation function. So let me see who remembers the correct aggregation function for the unit price. And I can see someone says main. Thank you, Benedine. So let me type main, open parenthesis. You can close it and come in between and work, or you can put in your column first. So the column is unit price. When you type unit price, you can see that it comes with a table name and it works. So this is really nice. And you can give it a name. Don't call it measure. Just call it lowest price. All right. And spaces are allowed. So you see how it is very simple when you understand the rules of DAX, you understand the syntax. And now you can work freely because you know spaces are allowed. You know what to do, that will work. So let's commit this as well. And the moment we commit it, it is created. Let's check here if we can find it. Lowest price is right here. So let's create a card and let's select lowest price for that card. So over here, we can see that it is here. Lowest price is this. So this is so wonderful. This is so nice. This is so nice and very, very easy as well. So number 6 is the highest price. Sorry, this is highest quantity. Highest quantity. So let's see how we can do that. So we create another measure. And then we have a function. This time the function is max, and then we are looking for quantity. So as I type quantity, IntelliSense will show me the rest of the code. And here I can see highest quantity. If you make a mistake with a name, you can always edit and commit again, and it will work. Even if you are done working on it, you can double click from here, from the data pane, and it will work. So let's take a card again, and let's select highest quantity. Now, highest quantity. Okay, so the highest quantity here says 10. All right, so this is not highest price, this is highest quantity. So if you check the data, you can see that quantity here, we have 88843, da, 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 da. So the highest is probably the 10. And that is exactly what we got. So these are aggregation functions. We have 3 more and we'll be done with today's class. This one is called a measure to count the number of orders. We want to know the number of orders we've received, and there is an aggregation function called count. So we will apply it on the order ID and we will get it to work. So let's go to the modeling tab, new measure. And this is called count. And then we have the order ID. And this is referring to the number of orders or total orders, total number of orders or number of orders. All right, so you can commit this as well, and you have your total number of orders. Let me click on it here, select it here, and we have 20. All right, so that is it. Other count 20. All right, so this is beautiful. We have 20 orders, and you can see that this is operating by filter context. The moment you provide a column, this means that there's going to be a filter on that column, and the aggregation is going to be performed only on that column. So that is called filter context. In our previous lesson, we explained what it is. It is just a concept, and you need to just understand it. And here we have the count all categories. Okay, so create a measure to count all non-empty entries in the category column. So we are going to count all categories. All right, so non-empty, that means any category that is not empty will be counted. So let's use the count A to achieve this. So let's go to modeling tab, new measure, and let's call this count A. And this count A, we are looking for categories. It's right here. And we are supposed to name this category count. So number of categories. Let's commit. And then let's create a card for it. How many categories we have? We have 20 categories as well. All right, so this is fine. This is really good. All right. Then last one is to count the total sales. Count total sales. Count total sales. Count total sales records. So create a measure that returns the total number of rows in the sales table. All right. So we are going to use count total sales records. So here we are going to use count rows to count the total number of rows in our sales table. So with this, remember the syntax, you just need to provide the table name. So let's go ahead and select a measure, still a measure. And this measure, we are going to use a function called count rows. And we provide the name of the table called sales. Close the parentheses. Remember, if you don't close your parentheses, you are going to see red here. So you have to close it, and then the red will go away, and you have blue. So this is the count rows. So we can name it as row counts. Let's call it row counts, and let's commit it. So let's see how many rows we have, and it's possible that we have 20 rows as well. All right. So these are simple, and very basic DAX. And with this, we've understood what DAX really is. DAX is an expressions language. It's a formula language. It's just there for creating formulas. Once you get used to it, nobody will tell you the type of formula you need for your project. When it's time to work on your project, you will know how to perform your calculation to arrive at the KPI you are looking for your wonderful report. This is really wonderful. As we complete this lesson, we are going to be working on a very powerful project that will be added to your portfolio, and a powerful project that you'll build upon tomorrow for so many things. And so let's continue and understand the basics of this particular lesson. And this course is really taking us somewhere. And this particular lesson, we've done a great job to introduce it well, to let you understand the various components of this particular topic. And you can see how easy it is to apply it. So in the next lesson, we'll move on to the next step, and we'll talk about advanced concept in DAX, and we'll cover what you need to know. Remember, you don't have to memorize, you don't have to worry, just get familiar with it. After going through this lesson, you will be exposed to what you need to know about DAX. And the DAX you will need for your projects, for your work, it will come with time. All right. Once you get into the field and you are working, all the DAX you need, you will have them and you will become an expert in DAX. For now, don't worry about them. Don't think about them. Don't think about them. Just get exposed to them. And today we've seen how the syntax of DAX is so simple. And we've been able to explain the syntax and we've been able to implement it. And you realize that it's becoming very easy for you. So thank you all for taking the time to be part of this lesson and also to watch this video. You can go over the video again to get better understanding. And like I said, if you didn't watch the previous lesson, please go back and take the previous lesson before this one. So thank you all for joining, and I will see you in the next lesson. Have a wonderful evening, and I'll meet you next time. Wish you all the best. Bye-bye.